Good morning. I am Dr. Senthil Murugan from Department of ECE, St. Joseph Institute of Technology. So today we are going to discuss about in digital electronics code conversion. So there are different types of code conversion. So we have binary code, gray code, XS3 code, etc. So how to convert one code into other code? Say example, today we are going to discuss, we are going to design binary to gray code conversion. So example, this is the binary number. Binary number, say 0, 1, 0, right? So this binary number, how I am going to convert into gray code? So binary to gray. So we have to follow some rules for converting binary to gray code. Before that, the prerequisite for this, we supposed to know the basic logic gates. Under basic logic gate, the XOR gate, exclusive OR gate, truth table is supposed to know. So in the logic gate, the exclusive OR gate truth table, there are two inputs A and B. There are one output X, is nothing but A XOR B. That means when both inputs are same, the output is supposed to be 0. When both inputs are same, the output is supposed to be 0. If any one input 0 or 1, the output is supposed to be 1. If it is inputs different means 1, same means 0. So this is the XOR gate logic. So we are going to apply this logic in binary to gray code conversion. Then you suppose to know the basic logic diagram. For example, XOR gate logic diagram you suppose to know. Then only we can get the design, in proper design, binary to gray code conversion. So let's start. What are the rules we have to follow? So whenever you are converting binary number to gray code, first step, the LSB, this is called least significant bit, this is called most significant bit, LSB and MSB. Keep your LSB as it is. So whatever the number present is maybe 0 or 1, keep the LSB, least significant bit, supposed to be in the first position. The same value will be in gray also. Right? To get the second value, compare first bit and next bit. You compare these two bits. So as per the XOR gate, 0, 1. 0, 1 means output is 1. Or simply we can say that if both inputs are different, 0, 1 or 1, 0, the output default supposed to be 1. If both inputs are same, the output is 0. So we have to follow this rule to get the gray code. So now I am comparing this 0 and this 1. So these two inputs are different, the output obviously 1. Right? Next compare these two bits. 1, 0. So here also both inputs are different, so output is supposed to be 1. So for the binary number 0, 1, 0, the gray number is 0, 1, 1. Right? This is a simple concept how to convert binary to gray code. So to design binary to gray code, we have to form the truth table first for all the bits. Then using K-map, we have to find the expression. With the help of expression, we have to design binary to gray code conversion. So we will go step by step. So the basic logic is what we are going to use is XOR gate, exclusive OR gate. Only this gate we are going to use for this binary to gray code conversion. So let's make the truth table for applying this particular rule, right? So let's start binary to gray code conversion truth table. Right? So while designing the binary to gray code, I am going to take 4 input and 4 output. The 4 inputs in the binary we have to name as B0, B1, B2, B3. This is the input for binary, and the output G0, G1, G2, G3. So you have to make the tabular column for these 4 inputs and 4 output. By applying the rule. What is the rule? If both inputs are same, the output is 0, right? Whenever both inputs are same, the output is 0. If both inputs are different, the output is 1. So going to apply this formula to get the final output of G0, G1, G2, G3. So let me write, as you know, the 8421 code. Based on the code, we have to fill the left hand side in the gray format. This is gray, sorry, this is binary. This is gray. So write 0, 0, 0, 0. For 0, we have to write up to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Up to 15, we have to find the gray number. So for binary 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. This is the input in terms of binary. So these are the B0 value, these are the B1 value, these are the B2 value, these are the B3 value. Now by considering this rule, I am going to get the gray code. So as per the rule already explained. For example, if I have 0, 1, 0 in terms of binary, how to convert it to gray? The first bit keep as it is. Compare these two bits. If it is differ 1, if it is same 0, if it is differ 1. So applying this rule, I am going to form the gray code table. So the first one G0. Always the first bit supposed to be same. So here it is 0 means here also 0. We always come from left to right. LSB to MSB. Least significant bit to most significant bit. So keep your 0 as it is. Now compare these two bits. Compare these two bits. These two bits same. If it is same, what is the result? 0. Next compare these two bits. Both inputs same, so output is 0. Compare these two bits. Both inputs same, output is 0. Got it? Similarly, we have to write for all the up to number 15, we have to write the gray format. So second one, first bit 0. Compare these two, same 0. Compare these two bits are same 0. Compare these two, different 1. Right? Next, second step 0. Compare same 0. Compare different 1. Compare different 1. Got it? Next, third one 0. First bits keep it as it is. Compare these two, same bit. Compare these two, different. Compare these two, same bit. Right? Next, first bit 0. Compare different 1. Compare different 1. Compare same 0. So applying this rule, I have to complete for up to 15. So directly I am writing 0, 1, 1, 1, 0, 1, 0, 1, 0, 1, 0, 0. You know how? First bit 0, I am comparing these two bits, different, right? 1. I am comparing these two bits, same, 0. I am comparing these two bits, same, 0. Got it? Then the first bit, I am comparing, different is 1, same means 0. First bit, different is 1, same means 0. First bit, different, different, different. So for 10, 1, 0, 1, 0, in terms of gray code, 1, 1, 1, 1. So 10 converted into 15. This is the conversion. Then 1, different, different, same. 1, same, different, same. Next, 1, same, different, different. Next, 1, same, same, different. The last one, 1, different, different, different. So see, 15 converted into 8. So if it is 15 in binary, gray la 8, right? So now we got the truth table for binary to gray code. With the help of this truth table, I have to form the K-map to get the expression, right? So I have to design the input supposed to be binary, the output supposed to be gray, right? So I have to draw the logic diagram B0, B1, B2, B3. The output supposed to be G0, G1, G2, G3. So what I have to find? What is the expression for G0? What is the expression for G1? Then G2, then G3. So I use here 4 different variables like B0, B1, B2, B3. So I have to form the K map. The K map will get the expression to make the design binary to gray code conversion. So final logic diagram we can get only with the help of K map. So we have to find the K map for G0, G1, G2, G3. So let me make for G0 the first K map for G0. So now only I am concentrating gray code. Wherever 1 present, we have to make 1 in the particular boxes. Rest nothing, right? Similarly for G1, G2, G3, right? So let me erase this. Let me cross check 0, 0, 0. So only 1 difference, 2 difference, 1 difference, 2 difference, 1, 2, 3 difference, same 1 difference, 2 difference, 0, 1 difference, right? So 1 remaining are 0. So here also 1 difference, 1, 2, 3 difference, 1, 1, 2, 3, all 4. So first bit difference, here also difference, same bit 0. Here first bit, same bit 0, different 1, same bit 0. Here first bit, same bit 0, different 1, 1. First same bit, different 0, different 0, 1, 1, 1, 1, 0, 1, 1, 0, 1, 1, 0. So this is only with the help of XOR gate, right? So only with the help of gray output, I am going to design K map, right? Let me erase this. Just keep my gray code alone. So first I am going for K map for the value of G0, right? So what is the expression for G0? If I know the expression, then only easy to design. So just see G0 all values, first bit all zeros, the output all 1. So if you compare with the binary, the B0 G0 value is same, right? The B0 and G0 value is same. Same means what? By default, the G0 is nothing but B0. So the input output of G0 is nothing but B0. So there is no need of K map because what I have in the B0, the same value in G0. But comparing G1, G2, G3 totally different. So I have to make the K map for G1, G2, G3, right? So let me go for G1, K map for G1. How many variables? 4 variables. So I have to make box like this. This is the basic idea of K map. I have to split it into 16 boxes. Right? So what are the input? B0, B1, B2, B3. Right? So you have to mention here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what's supposed to here? B0, 0, 0, right? Like 0, 0 means B0 bar, B1 bar, B0 bar, B1, B0, B1, B0, B1 bar. 0, 0, 0, 1, 1, 1, 1, 0. Similarly here, B2 bar, B3 bar, B2 bar, B3, B2, B3, B2, B3 bar. This is the basic rule to design the K map. Now I have to fill the numbers where 1 present in the particular value. So this output for 0, this output for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So where 1 present, I am going for G1. Now at present in G1. So G1 where 1 present, the value of 4, 1 is present, right? So I have to mark 1 in the 4th box. Then 5, 1 is present, 5. Then 6, 1 is present, 6. Then 7, 1 is present, 7. Then 8, 9, 10, 11, 12. 8, 9, 10, 11, up to this. Here all 1 present, 8, 9, 10, 11. 8, 9, 10, 11. So rest of the thing is 0. So we don't need to mark anything. Now grouping. So the basic KMF grouping, if you know, we got group, single grouping, double grouping, 4, 8, 16. These are the possibility of 4 variable KMF. So here I can go for 2 4 grouping, right? So I can go for this as a 1 4 grouping and this as another 1 4 grouping, right? If I make grouping like this, the all term will be eliminated. The only B0 bar and B1 here, B0 B1 bar. So output of G1 is nothing but B0 bar B1 plus B0 B1 bar. Clear? This is nothing but XOR gate. It can be replaced by B0 XOR B1. So this is the output for gray code B0 X1 XOR B1. Right? So what is G1? So final expression G0 is nothing but B0. G1 is nothing but B0 XOR B1. Now similarly I have to find G2 and G3. Same came up for G2 and G3. So let me do again came up for G2. Came up for G2. So again 4 variable came up. This is 4 variable came up again. Same rules we have to follow to get the 4 variable came up. The inputs are B0, B1, B2, B3. So you get B0 bar, B1 bar, B0 bar B1, B0 B1, B0 B1 bar. Similarly here B2 bar, B3 bar, B2 bar, B3, B2 B3, B2 B3 bar. Right? Again names 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now we are on G2. So here G2, wherever 1 present, 2, 3, 4, 5. In 2, 3, 4, 5, I am getting 1s. So let me make 2, 3, 4, 5. Then 10, 11, 12, 13. 10, 11, 12, 13. 10, 11, 12, 13. So now I have to do the grouping. Is there any chance of 8 group? No. Then 4 group? Yeah, obviously. I can group these as a 4 group and these as a another 4 group. Right? So while grouping these two, which is the common term? B2 bar. Which is the common term? B1. So the output of G2 is nothing but B1 is the common term and B2 bar plus these two. These two. What is the common term? B2, common term B1 bar. So B1 bar, B2. Right? So again this is like A, B bar plus B, A bar XOR gate. So it can be replaced as B1 XOR B2. Right? So what is the output of G2? G2 is nothing but B1 XOR B2. Right? Now G3. I have to find what is the expression for G3. So again came up for G3. Came up for G3. Right? 4 variable. While writing the number, very careful. If you misplace the number, the output expression will be changed. Again, the inputs are B0, B1, B2, B3, B0 bar, B1 bar, B0 bar, B1, B0, B1, B0 bar, B0, B1 bar. Right? Next, this side, B2 bar, B3 bar, B2 bar, B3, B2, B3 bar, B2, B3 bar. Sorry, right? So now we are going to design KML for G3, where 1% we have to identify. Right? So now make a numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Identify where 1 present in the particular column, right? 1, 2. In 1, 2 I have 1 present, so 1, 2. Then 5, 6. Where 5, 6. Then 9, 10. 9, 10. Then 13, 14. 13, 14. Right? So you just check in the truth table. Wherever 1 present, just replace the 1 in the K-map. Right? So what is the option of opportunity? Possibility 16 box all 1? No. Is possible of 8 grouping? No. Is possible of 4 grouping? Yes. I can do 4 grouping. This is a 1 4 grouping, and this again another 1 4 grouping. Right? So now I have to get the expression. If I make this as a 4 grouping, these all time will be eliminated. What is the result? B2 bar B3. So for G3, the output is B2 bar B3 plus again this one B2 B3 bar, B2 B3 bar. Again it should look like A B bar plus B A bar. Again it's a XOR gate, so I can replace like B2 XOR B3. So the output of G3 is nothing but B2 XOR B3. Right? For designing binary to gray code, we need the expression. With the help of K-map, we found all the values of G0, G1, G2, G3. So using this expression, we have to design binary to gray code conversion with the help of logic gates. Right? So by seeing the output B0 XOR B1, B1 XOR B2, B2 XOR B3. By default, we are using only the XOR gate. The symbol of XOR gate, this is the symbol of XOR gate. 2 inputs, 1 output. Right? With the help of these logic gates, I am going to design binary to gray code conversion. Let's see the final logic diagram. Now we are in the final stage, logic diagram or implementation. Logic diagram of binary to gray code conversion. Right? So we got the output of G0, G1, G2, G3. These are the output. With the help of the inputs B0, B1, B2, B3. So let's see the inputs. What are the inputs? B0, B1, B2, B3. So these are the 4 inputs in terms of binary. We are converting into gray. That is G0, G1, G2, G3. Right? So left hand side the inputs value B0, B1, B2, B3. Right hand side output value G0, G1, G2, G3. Right? So now I have to design. So what is G0? What is G0? G0 is nothing but B0. Is there any gates? Not required, because B0 and G0 the value is same. If you see the truth table, what is the B0 value present? It's same value in G0 also. So there is no logic gates coming under G0. So B0 is nothing but G0. There is no gates at all because both values are same. Now come to G1. What is G1? B0 XOR B1. So we have the B0 and B1. Just make a line from B0. This is B0, and take a line from B0. B1, make a XOR gate. Now this is for output G1. What is G1? B0 XOR B1. B0 XOR B1. So we got G1. Similarly G2. What is G2? B1 XOR with B2. So I have B1, B2 inputs. So let me take line from B1 and B2. And here make XOR gate. So I am getting G2. So G2 is nothing but, by see the diagram, B1 XOR B2, B1 XOR B2. The final one G3. What is G3? B2 XOR B3. So we have B2 here, B2, and B3 here. Just make a XOR gate and connect. You will get G1, G2, G3. So this is the logic diagram for binary to gray code conversion. Right? So what are the steps we have followed? First, we have to make truth table. right? First make the truth table with the help of the logic. Logic means if both inputs same, the output is 0. If both input is different, output is 1. With the help of the logic, you have to make the truth table. From the truth table, we have to design the K-map, right? 4 variable K-map. After designing the K-map, from the K-map, you have to identify the expression or logic function, right? From the K-map, we have to get the expression. The expression in terms of what is G0, G1, G2, G3. We have to identify the expression for G0, G1, G2, G3. And the last step, after finding the expression, the logic diagram. The help of XOR gate, right? The help of XOR gate. So this is the how we are converting binary to gray code, right? The same procedure we have to follow in gray to binary also, but slight changes. Let me explain the changes alone. You can try yourself to design gray to binary. So clear? So binary to gray code. These are the input. These are the output. How I am getting this logic diagram from the expression, how I got this expression from the K-map from the truth table. So you have to follow, find first truth table you have to form, from the truth table K-map, from the K-map expression, from the expression logic diagram. So this is how we are converting binary into gray code. Let me give the hints how to convert gray to binary. So what we followed the rules binary to gray. The example 0 1 0 means first bit keep it as it is and compare these two bits. If it is differ, the output is 1. If it is same, output is 0. Compare these two bits. If it is differ, output is 1. This is the formula for binary to gray, right? If it is gray to binary, in reverse order, my input is 0 1 0. What will be the output? Right? So here, make your first bit as it is. Right? Now we have to compare what result I got with the result with the next bit. That means this is my result with the next bit. Just compare, these two bits are differ. So what is the result? If it is differ means output is 1. Right? Now this is my result. Now result with the next bit. 1 0. Differ, output is 1. Got it? So this is in terms of gray, this is in terms of binary. You just compare binary to gray. 0 1 0 converted to 0 1 1. Same 0 1 1 converted into gray 0 1 0. Right? So this is the conversion for binary to gray code and gray code to binary. So same rule, you have to form the truth table and from the truth table K-map to expression logic diagram. Right? Thank you. The logic here also, same logic we are going to apply. So instead of finding G0, G1, G2, G3 in gray to binary, what we have to find in reverse order? What is B0, what is B1, what is B2, what is B3? Right? Same way, from the logic diagram, the first rule we have to follow for gray to binary, truth table, in terms of input is supposed to be gray, G0, G1, G2, G3, the output is supposed to be B0, B1, B2, B3. So you have to write the values with the help of 8421 code and then K-map to find B0, B1, B2, B3. From the truth table, you identify what is B0, what is B1, what is B2, what is B3. Same 4 variable K-map. From the K-map, get the expression. From the expression, you have to design the logic diagram. The steps, everything same, only the rule is different. If it is binary to gray, keep your first bit as it is and compare next bit with the result if it is gray to binary. Right? So binary to gray, keep your first bit as it is compare the input 2 bits as a output. If it is gray to binary means first bit as it is the result with your input, then this is called gray to binary, right? Thank you.